we present our work of generating 3D people in scenes without people. We see that many high-quality 3D scene scans exist. However, we find that humans are not included in these daily environments. This very important factor is missing and needs to be addressed. Generating people who are posed naturally in the scene is very challenging and usually involves extensive manual work. Our goal is to automate this process effectively. It can then be used for applications such as AR/VR, synthetic data creation, movie game production, and computer-aided design. In a 3D scene, we set up a camera and record the depth map and semantic segmentation from that camera view. At the same time, we represent the human body by several parameters. With these parameters, we can use the simplex model to obtain a body mesh. Since simplex is differentiable, the constraints applied on the body mesh can update these body parameters. We use conditional VAE models to generate body parameters conditioned on scene representations. This one-stage model is to generate all body parameters based on the scene, while the two-stage model is to first generate body global translation and orientation, and then to generate the body shape, pose, and hand pose. With ground truth scene-body representation pairs, we minimize this loss function to train the model. This loss function consists of 5 terms. Specifically, the contact term encourages plausible body-scene contact, and the collision term discourages body-scene surface interpenetration. Using the trained model, we can put bodies into an empty test scene. We can see this body has plausible configurations, but implausible interactions with the scene. To refine generated results, we perform an optimization step to apply the human-scene interaction constraint in the test scene. We can find that this body-scene interpenetration disappears. To train and test our generative model, we expand the prox dataset to proxy with virtual walls, virtual cameras, and mesh semantics. With the virtual walls, we can always obtain complete depth maps for any virtual camera inside of this room. We follow the Matterport 3D semantics and annotate scene mesh vertices by hand. We also use the Habitat simulator to cruise in Matterport 3D meshes to create another test set. Our trained models can thus work directly in Matterport 3D scenes, as the scene semantics are the same. We quantitatively evaluate our results by diversity, physical plausibility, and naturalness. To evaluate diversity, we use the cluster ID Shannon index and the average cluster size. The higher these two scores are, the better. The results show that the S1 model without human scene loss performs better. What's more, the geometry-aware fitting can consistently improve performance. The physical plausibility is reflected by 2 scores. Here too, the higher the better. The results show that the S1 model outperforms other methods, and the fitting can consistently improve performance. We run a user study to evaluate the naturalness. The user interface is on the left. On the right, we can see that the S1 model with post-processing is better than other methods, but worse than the ground truth. Here, we can see that generated people have diverse shapes, natural poses, and plausible contact with the scene. We find 2 types of failure cases in our experiments. First, our generative models produce failed cases probably because the test scene is much different from training scenes. These failed results ignore test scene structures and have implausible body-scene interactions. Second, the scene geometry fitting does not always work well. It might lead to physically plausible but abnormal poses. Since we did not model physics like gravity, the results after fitting might float and touch the ceiling. In our trials, we find this fitting process is not robust to noisy scene structures. In conclusion, we propose a new task of generating 3D people in scenes without people. We also propose effective methods, create and expand some popular datasets, and propose several metrics for systematic evaluation. We believe our work could be a benchmark for this task. Thanks for watching.